Do you have a child who loves electronics, but you don't have the money or the budget for all the kits and tools? Well, in this video, I'm going to show you some free online lab simulators that your child will enjoy, and so will your budget. Stay tuned. Hi, my name's Steve, the host of Your Technology Coach, where our purpose is to empower the homeschool and public educator community with engaging and effective STEM activities and classroom resources. So in this video, we're going to address how do I find online activities that my kid will enjoy and won't break my budget. Well, if you have a computer or a laptop, I'm going to show you where to go and how to get started with electronic online simulators. All right, guys, here we go. So there are some really cool simulators out there that cost absolutely nothing. We just need to know how to find them, right? So the first thing I did when I was looking for these kind of resources is I went on to a basic Google search. You know how to do Google, Bing, Yahoo, whatever your favorite is that you like to use. And I typed in circuit simulators for kids. You can also type in electronic circuit simulators for kids, or just type in circuit simulators, and you're going to get a bunch of different things here that are going to pop up. Now, just a bit of warning, when some tips when you're doing some online searching, that companies pay to get top ranks, so you want to really be careful about using anything that says ad next to it. Some of those may actually be pay for types of simulators. So scroll down, kind of once you get past the top ads and stuff, there's usually some really good things that you'll want to take a look at. I actually use the Circuit Construction Kit, which is from the PHET program out of Colorado. And we're going to use that one today, which I think you're really going to love it. There are some other ones you can go through and just kind of click and see what they look like. Some of them, though, might be pay. They start out as look like a nice little simulator you can launch right away. But this one here, I think, is great. It does cost money, but it gives you a very limited scope of working with the circuits. And then at some point, it tells you, hey, you're going to have to pay for this. But this is a little more advanced than what we're going to do today. So I'm not going to work with this one. But some point in the future, I might do an overview of this for more of an advanced kit. So going back to the search that I found, all right, so there was one right here called Circuit Construction Kit. So that one here I like a lot because it's free. It's totally free. So when we get into this, there's two ways you can do this, right? So there's the online view. You can basically click right on this, and it's going to start you in a window, and it's going to look similar to this. And then it's going to let you do everything you want to. Again, though, you have to have an internet up and running in a browser in order to do the web version. Or you can hit the download button. The download button will actually bring a file, and it's an HTML file, and it actually will load it on your computer locally, so that if you want to just take it with you on a laptop, if you're going on vacation or you're just going on a road trip, install this and run it right from the laptop with no internet connection whatsoever. So I like that feature. So when we get into the actual lab, this is what it's going to look like. So when you launch it, again, you can launch it from the web browser, and you're going to get two choices to go with. The intro is basically the same as the lab. It just has less features, but I like to go right for the gusto and hit the lab simulator. And once you highlight it in yellow, you can click it again. And this is your main screen. This is your workable area, or your electronic palette, if you want to put a artsy type of name to it. So in this video, I'm going to be referencing some of the other videos I've done, namely the how to build simple circuits and the STEM kit review for Snaptricity. So we're going to take the examples from that video and we're going to apply it to the simulation environment so we can get a real world feel of how something in the physical world that we did translates into the virtual environment that we're about to do here. All right, so let's take a look at the sidebar. So on the sidebar, these are all the basic components. Again, it's a very, I'm going to say a scaled down version. So we're not going to have all the things in a kit that we would normally have and pay for. As I find more resources online, I will make sure to post a video about it. So if we go down the sidebar, these are very easy to use, and they're actually very easy to configure. And any child that has already worked with electronics is going to probably pick this up pretty quick. Parents, if you've worked with electronics a little bit in the past, this is definitely going to be right down your alley. So if we kind of scroll down here, we have our wire, we have batteries, light bulbs, resistors. At the top here, we have additional resources and different switches. But one thing we'll notice when we start working this is that all these elements here are configurable. So I'm going to show you what that means here in a minute. And this is kind of funny. These are all our types of resistors. So we talk about resistor as something that will negate or restrict the flow of electrons in a circuit. So this is just some examples of things you can kind of test and say, okay, how much resistance does a dollar bill have? Do electrons flow through a dollar bill, or a paper clip, or a coin, an eraser? Some of these are actually what we would call insulators. An eraser has rubber content to it, so it's technically an insulator. Some of our metallic devices here are conductors. A hand would actually be a conductor depending on how much voltage, amperage is going through the circuit. That's a safety concern. A dog wouldn't be something you would put in a circuit. It's definitely a conductor if the voltage is right. And a pencil. So pencils usually have graphite in them, which can be a conductor. And some point down the line, we can see how that works on our circuit. All right, well, let's start with building our series circuit. And this is going to be referencing back to the video that I just did recently on building simple circuits, Snaptricity kit review. And we're going to start with our battery pack right here. So again, you can just drag and drop things we want to put in here. This is really simple. And once I have my battery in place, I can click it and I can choose. If you remember, the voltage of our other kit that we used was 4.5 volts. So I'm going to drop this down just so we have a real world simulation from the physical to the virtual. There we go. 4.5 volt battery. And the next thing I'm going to do, if you remember, we had an ammeter that we had connected. And the ammeter basically told us the current that was running through the circuit. An ammeter always has to be connected in line, not on the outside of a circuit. All right, from there we added a battery. I'm sorry, not a battery, it's a light bulb, Steve. So I'm just going to put some conductors between them, just so we have a little more of a dimensional area here. And I'm going to put another wire, and you can change the length of these. You can change the direction. Put them any way you want. And I'm going to put my next my next light bulb in, and another wire. And we'll put another light bulb right there. You know, if you're not figured out by now, I like using a lot of conductor. All right, we'll put another conductor there, and a switch, and a conductor. And you can make this as fancy or not as you want, very simple or very extravagant. All right, so if you remember our lab in the other video, we created a series circuit. Now, if you remember the outcome of this, were the lights dim or were they bright? Well, let's find out. So there we go. We clicked the little lever here, which is our switch. We close the circuit, which creates electron flow. And what we can see is these lights are very dim. So let's grab our voltmeter on this side. We're going to drag it down here. All right, our voltmeter is going to tell us, let's kind of hook up our leads here. So all we have to do is kind of drag the first lead, put it one location, take the other lead, put it at the next location. And we're getting 1.5 volts across this circuit. Now remember, every light bulb, every component here has resistance. These here, if I click on it one time, these are 10 ohms. All right. All right. So if I take my lead and I put it on another area of the circuit, you can see 3 volts, 3 volts, 1.5 volts. Let's put this one up here. 3 volts, 1.5. All right. So depending on the load that the resistance is creating is going to tell me exactly what my voltages are. And if you see here, my current is still 1.5 amps. I'm sorry, 0.15 amps. So it's 1.5 milliamps right there. So if it was 1.5 amps, that would be a problem. We would be in some serious trouble right there. But that is a safe load right there. Okay? So there we go. That is our simulated circuit that we created from the physical circuit for series electricity. All right, well, let's move into our parallel circuit. So this circuit is going to refer back to my video on simple circuits, project number 21. And this is going to use 3 light bulbs and a power source and a switch. So I'm going to just pull out my 3 light bulbs, get my inventory going here, my battery, and my switch. And then we'll fill in the cabling or the conductors as we go here. So if you remember, we had a 4.5 volt battery, which was still consistent with our series circuit. So to change that, I'm going to click once on it, and I'm going to bring this down using my slider bar and my arrows to 4.5 volts. And if I click anywhere out here, it will deactivate. Activate, deactivate. All right, I'm going to put my switch in place. And contrary to the last video, it's sometimes good to have all your parts laid out and ready to go. That way it's kind of simple, just kind of connect all the wires. And because the nice thing about this is you can make it look pretty fancy and make it look really close to an actual circuit, which is just for the visual purpose and understanding how things work is very good to know. All right, so there we go. So anyway, again, remember, like I said, you have resistances on each load or each component, but I'm going to leave those at 10 ohms. And remember, ohm is a measure of resistance, or how electrons are able to flow or not flow through a device. So we either have, when we create a light bulb, we have resistance, it's creating more heat, and that will reduce the amount of voltage and amperage going through the rest of the circuit. All right, so let's connect our wires. We're going to put these in place. And remember, we're doing a parallel circuit, so it's a little different. Things aren't in a racetrack format like they were with the series. So I like to have things nice and clean when I'm putting them together. So I try to keep things as uniform and right-angled as possible, and that's a good habit to get into, because as you get into drawing schematics and design work, you want to be able to have very clean examples and patterns and designs, typically at right angles when you're designing circuit boards. Okay. Almost there. So if you notice, now we have our light bulbs in a parallel. Again, this is a geometry term. We have things in parallel and linear at the same time. I'm going to attach that. And our last connector here. And if you notice how I just put this together very, very easily by pointing and clicking and dragging, All the components I used were in the first bar here. We do have additionals, like we said down there, which we're not going to use in this video. And remember too, I also have my schematic version, so I can click this button and it will show you the schematic version or the professional way things would look on an actual electronic diagram. But for our purposes, we're going to keep it on the more the visual view of things so we understand what we're working with. All right, so I'm going to bring my voltmeter down here just to have that ready. Again, I can just drag it out of the bar, and we are going to close our circuit. All right, so let's take some observations here like we do with any lab experiment. So we have our first light bulb in our circuit, which seems to be a little brighter than the other two. Now, if I'm going to do on this mode here is I'm going to connect my first lead there, and I'm going to bring my next lead up here first. Now again, this is measuring directly across the battery, so I will get the 4.5 volts. That is standard. Now again, it's got a minus in front of it because I've technically reversed polarity because I have the first probe on the positive end. I'm going to go ahead and put this on this end here and then throw it on this side. There I have 3 volts. Down here I have 4.5 plus now because I put my probe on the opposite end here. So now my polarity is going the right way. So I have 4.5 volts, which I have no load in between here, so there's no resistance. If I put it on the opposite side of my first light bulb or my resistor, I'm getting 3 volts here. If I put it to the next one, I'm also getting 3 volts. So you can see the voltage supply is split between these two in a parallel circuit. If I put it up to this one here, I still get 3 volts. Now in the example we did in the actual lab, the physical lab, remember we took out a conductor and we just crossed it again, and we made a short circuit. We took the other 2 resistors or the light bulbs out. So to do that, I'm just going to click on this circuit right here, this little branch. I'm actually going to turn my power off first. Click here. I'm just going to hit the cut button, and that breaks my circuit. So now what I'm going to do is I'm going to go ahead and pull that right down here. So now what I'm going to have, let's just go ahead and put this up here, and we'll put this one on this side, and we'll close the circuit. And there we go. See how much brighter this light bulb is now because it's pulling the full 4.5 volts out of the battery, whereas it had to share the voltage with the other light bulbs or resistors on the circuit. So if you found this video to be a valuable part in your educational program, please hit the like and subscribe buttons below and share this video with others in your community. Also, don't forget to check the descriptions below for valuable links and resources. My name's Steve, the host of Your Technology Coach. Thanks for watching.